What's up, everyone? Today we're talking about interest conversions. You should recognize this formula at the top of the page from high school. If not, it's fine. We're going to dive into it now and try grasp a bit of an intuitive understanding of what's going on. So let's talk about it. On the left, we've got your nominal interest rate, and on the right is your effective interest rate. IP is your interest compounded yearly. IP over P is your interest applied each period. And then the P, this is just the number of compounding periods per year. And then on the right-hand side, we've got our effective annual interest rate. So for all of our financial maths calculations, we're always trying to get our effective annual interest rate, or just our effective interest rate in general, whatever period it may be for, because that shows us the interest that we're actually earning in a year. As for this nominal interest rate, we just use that to measure, not putting that into our calculations. So if we dive, IP is our Peatley convertible interest rate, which means it's a nominal. As soon as we hear convertible, we must know that it's a nominal interest rate. And then IP over P, this whole thing, this, in this formula, right, this is an exponent, this P, that's an exponent. This P is not an exponent, that's just notation. It's IP over P to the power of P. You see that, you can't see that. But that P there, that's an exponent. This P here, that's not an exponent. Anyway, so in the numerator, we have that IP, which we said is our Peatley convertible interest rate. In the denominator, we have a P, and this exponent is also a P. That P is just the number of compounding periods per year. So if it's monthly, convertible monthly, that would be 12. Convertible quarterly, that would be 4. Semi-annually, it would be 2, and so on. So let's talk about it. Let's say, for instance, we have let's say you have a question and it gives you a 5% convertible monthly interest rate. And for whatever reason, maybe our calculation is going in a way that we need a monthly effective interest rate. So what we're going to do is we're going to take your 5%, 0.05, divided by 12, because we know it's monthly. And then this right here is going to give us our okay, this here, just by dividing our convertible monthly interest rate by P, gives us our monthly effective interest rate. And let's say now we want to get this monthly effective interest rate to a yearly effective interest rate. That's like the most common one, that's your standard. That's our IEFF. So let's say we want IEFF, sorry. Then what we're going to do is let's name this X. You can put that in a calculator. I'm just off the top of my head. So we have our monthly effective interest rate. And to get this monthly effective interest rate into a yearly one, all that we do is we're going to go 1 plus X, which is the monthly effective interest rate, to the power of 12 minus 1. So in this case, I'm putting it to the power of 12 because here at the bottom, we have to the power of 12. That was our monthly. So we only have a monthly interest rate. We need to grow this by a factor of 12 to get it to a yearly one. Let's say if this wasn't monthly and it was quarterly, we would be dividing by 4 and putting to the power of 4. And obviously this X would change respectively. So that's that. And it's also worth mentioning that a compounded yearly interest rate is equals to an effective yearly interest rate. This can be easily mathematically proven. You'll just maybe plug some ones in by the P's. And then this formula as a whole can also be proven. You can do that in your spare time. I won't dive into that though. And then let's dive into some examples here. So convert each of the interest rates to an effective annual rate. That's nice and simple. 5% per quarter effective. 5% per quarter effective. So to get that to an annual effective rate, all we're going to do is we're going to go 1 plus 5% to the power of 4 minus 1. Okay, so that's going to be 1.05 to the power of 4 minus 1. Plug that into a calculator. So you can come out at 0.215. I just thought these numbers will come out made, so these interest rates are going to be funny. So this is a 21 interest rate effective annually. The second one, 7% per annum nominal convertible monthly. So let's do it because, in the papers you don't have lots of time, whatever you may be doing. 7% convertible monthly. So let's get it to an effective monthly. 0.07 divided by 12. What is this? 12 is equals to 0.005833 and so on. So this is a monthly effective now, this number that we've got here. Sorry, so to get this now to an annual, we're just going to go 1 plus 0.005833, whatever, to the power of 12 minus 1 equals, and then that's going to be 0.07229. However, let's run back to our formula quickly, this red one that we started with. If we just use that formula, which I'll just write it here for you, it's 1 plus IP over P to the power of P. So right, we're asking for this effective annual interest rate. So let's just plug everything into our formula and we'll see if we get the same answer. Let me do this in another color. We'll do some mathematical gymnastics, get IEFF. Plug that in the calculator, we get which is equals. So you see, whatever way you want, just thought I'd give you two ways. And now this question, slightly more expensive, but nothing crazy. 5% effective per month for 5 months. Let's jump. So there's two parts, right? We can see that the 5 plus 7 is equals to 1 year. So we're just trying to get one effective interest rate for the whole year. So 5% effective per month for the first 5 months, or just for the 5 months, that would be 1.05 to the power of, for the 5%, 1.05 to the power of 5 multiplied. In the second part, we have 7% effective per quarter one. But this is per quarter for 7 months. So we're going to put 7 over 3. And the 3 is there because we have a quarter is 4. And then each quarter of a year is 3 months. So let me just make a note here that might make the exponent here. The exponent is the number of compounding periods in that time interval. That's a mouth note. So it's the length. So it's the length of time, which is 7, over the length of the compounding period, which is 3 months, because a quarter of a year is 3 months, right? So take that down. I need to remove it. I don't have space. Let's go on. So now we're here, right? But we can't forget, because if you put this in your calculator, you'll see you get 1 point something something something, which that's not what we're looking for. So don't forget to minus the 1, and then punch that in your calculator, and you'll get. When you're doing interest rates and you're doing a calculation, just at least keep 5 decimals, because these calculations will be doing funny things to your calculator. Just keep up at least 5. And I just left one simple interest for the vibes, maybe you forgot it. So remember, simple interest is not compounded, so it's very simple. 3%, very simple. 3% per month, simple. So we want an annual effective. What we're going to do is go 12 times 3%. 12 times 0.03 equals 0.6. Cool. And that's it. Hope this helped.